Hello and welcome to our webinar on tangents of circles. In this section there are going to be a lot of definitions, so first thing you want to do is draw your circle and label as many things as you can. I will go through a few of them. I'm not going to go through any of these because we're going to cover all the definitions in class. There are some flashcards that you will need to go over. You will need to get all these definitions, and they're on the wiki page right above these videos, so hopefully you saw them. Here they are. This is the wiki page. I haven't added the videos yet, but the videos will be added, so you just click through these and you can see all the definitions are there. I will kind of highlight them throughout the video, but I just wanted to make sure that you know that where they are. They're on the wiki on that page. So moving on to the next page. Like I said, you could follow this link. It'll take you to those flashcards also, but you need to have all of them. There's like 18 definitions in there. These are other vocabulary words. Some of them are in there, some of them are not. Make sure you get these down, pause it if you need to. I'm going to move along because I'm going to go over some of these things. So first thing we will do is talk about a circle, and hopefully you know what a circle is. A circle is a point that is a group of points that is equidistant from a single point in the center. So I have my single point, and all of these points around the outside should be equidistant from the center. That point is the center of the circle. The radius is, I will do the radius in red. The radius of this circle, and actually I'm going to draw a better circle than that. I'm going to delete this one and grab a circle from up here. And if I draw a circle, so there's a good circle. From the center of this is the center point, and basically from that center point, all the points are equidistant from that center, and from that center point, this line that is from the center is considered the radius. So the radius is the red line over here, so radius is red. Congruent circles are basically any circles that have the same radius. So if I copy this one right here, if I make an exact copy of this, I make an exact copy and paste it, this circle right here, because it has the same radius length, it would be a congruent circle. So we'll say if this radius was 10, this radius was 10, those circles are considered congruent circles. The diameter is just 2 radii. It's actually the whole distance across. So diameter means distance across, so I will draw a diameter with a blue line. And you can get the formal definitions from the flashcards. These are just my definitions and just kind of me talking you through them so you can see what we're talking about. So the diameter is the blue line. Now the next one is a new term, a chord. And I'm going to take this circle right here. And a chord is basically any line that touches 2 points on the circle. So a chord looks like this, and it's inside the circle. So there's a chord. The diameter is also considered a chord. The diameter is actually the longest chord in a circle. So that's a chord. So we'll highlight the chord in green. And then the last one on this page is a secant. And a secant is a line. So the difference between a chord is a segment, and a secant is a line. Okay? But they're going to look kind of similar. A secant, on the other hand, is a line that goes through the circle and touches it at 2 points. So a secant goes all the way through and keeps on going. A chord is just a line that touches any 2 points on the circle. It's just a segment. Okay, so there's the difference between the two. They're basically the same idea. One is a line, one is a segment. So that's really all there is to it. So moving along, if we go back to our circles here, let me see if I can get my circle to come back. So here's my circle. And all of these are in your book on page 595 through 600, but we don't have access to a book right now, so we're not going to talk about that. You can look them up. A tangent is our new point, and a tangent is basically a line or a segment or a ray, and that's part of the definitions that you need to look up, that touches the circle at one single point. And so I'm going to be a little more accurate with a tangent because I want a nice straight line for that. So if that blue point right there is where the tangent line, the red tangent line, is touching the circle, a tangent is the line. It's the red line. It could be a line, it could be a ray, it could be a segment. In this case, I'm going to draw it as a line. So a tangent is the red over here. Now let me jump down here to the bottom one down here. The blue is the point of tangency. The point where the tangent line touches the circle is the point of tangency, and that's also in your definitions. You just need to make sure you have them, and make sure you have all of these things. And so then, let's see, all right, so then all of these guys kind of go together. So we have tangent circles, and tangent circles are basically circles that touch at one single point. So I'm going to actually take this whole thing right here because this is all very helpful. Tangent circles could be like this. Those are tangent circles. There's my one tangent point that they're touching, and so they touch at one single point. They're also tangent circles. Let me shrink this guy down. These are different type of tangent circles, but they're still tangent circles. These are also considered tangent circles. Okay, so just so you know, there's different drawings for them. There's the one where the circle is outside. Those are tangent circles. And then there's ones where they're tangent on the inside, and those are also tangent circles because they're only touching at that one single point. Okay, so then, along with that, the red line in both cases are the common tangents, because that is the point that they both have in common. And so that's one of the things that we talk about as common tangent. So then we have concentric circles. Concentric circles I always think of as a dartboard. So I just leave this, and so if I'm going to do concentric circles look something like this. And so concentric circles basically have a point in the center, and they're equidistant. Basically you'll have a radius, and then you'll have a different radius for the bigger one, but they have the same center. So concentric circles have the same center. Okay. Tangent circles have same tangent point. Okay, so that's the difference. And I always think of concentric circles, in my thought whenever I think of concentric circles, as a dartboard. Dartboard is an awesome example of concentric circles because everybody's seen a dartboard, and those are circles. The different rings of the circle are concentric circles. Common tangent, okay, so we already talked about common tangent. Interior of a circle, that should be fairly obvious. It's like interior of your house. This is inside the circle. Inside the circle, and this is exterior, like outside your house, exterior, outside the circle. So those are all the definitions. That's my little talk about these. Make sure you get the formal definitions because you'll need them outside, and so that's really where we're going with that. So then we have different points of intersections for a circle. Circle can intersect at 2 points. That's this guy right here, and you can see if you have 2 points of intersection, you can have those 2 points, then they're going to cross at 2 points. You're only going to cross at 2 points, 1 point, or no points whatsoever. So 2 points are when the circles look like this and they overlap. We have internally tangent, that's what I was talking about before, where the circle is inside and you have your 1 point of tangency. You have externally tangent, where you still have your 1 point of tangency, but the circles are outside each other. Then there's concentric circles, which would be this guy right here with like the same center. We already talked about that. And then also the no points of intersection. So your options are either 2 points, 1 point, or no points of intersection. These last two over here are no points of intersection. So then we can go through, and we have a whole bunch of theorems that go along with this, and so we're gonna kind of go through these and make sure you get these copied down in your notes. So it says if a line is tangent to a circle, that's the line line L up here, then it is perpendicular to the radius drawn to the point of tangency. So point P is the point of tangency up here, and basically we're saying if line L is tangent to the circle Q, then we can say that QP, line QP, is perpendicular to the line we'll call L, and that's really what we're talking about out there. So they're perpendicular to one another, and that's really what this theorem is talking about. So in the plane, if a line is perpendicular to the radius of a circle at an endpoint, then we know that a line is tangent to the circle. So basically this is the reverse of the previous one. So we have L is perpendicular to PQ, and then at point P, then we can say L is tangent to the circle. So we're just repeating what they set up above. We're just reversing the operation, the circle Q. Okay, and we use this little circle with a dot to represent circle Q. So we're basically saying these two theorems are reverses of one another. So first one says if a line is tangent to the circle at point P, then we can say the tangent line, the radius is perpendicular to L. This one is saying the radius is already perpendicular to L, so we know the line is tangent to the circle. Just gives us some license to do some things with the circles and gives us more information about the circles. So here's an example of where this might come in handy.